someone I don't forget, Lex. Don't tell everybody my password.
I just told Canyon, but that's all.
Alright, so, talk about how we're going to use this graphing calculator initially, okay? And it's to help us create something called constructions, okay? A construction, okay, right here is the drawing of various shapes, okay, using only a compass and only a straight edge, okay? Now we say or a ruler because usually that's the most convenient straight edge that we have, okay, or meter stick or yardstick or whatever, okay? But we don't want to use a yardstick or meter stick or ruler in this manner, okay? Because I don't want markings on it. We're never going to measure something directly, okay? Measuring something, I want to say, what's the length of AB here? That's considered direct measurement right there. And I say it's 1 foot, 1 inch, right? Okay? I don't want that. I want to turn it around and I want to use that. So there's no markings on it. Does that make sense? Okay? And we'll talk about why we do that here later on. Okay? A compass. Let's see here where my compass is at. All right, there's a lot of different versions of compasses that maybe you've seen in Walmart or in previous grades or whatever, classes. This is probably the most standard type of compass you're going to see. Okay, it's got a wheel in the middle, allows me to change the distance between the legs of the compass, right? You guys have all seen these before? Okay. Now, all this is designed to do for me is to create a distance between where my fingers are, okay? Distance between this lead and the distance between that needle. For instance, if I want to look at that segment right there, that little blue segment that's up and down in that table. If I want to take that distance and replicate that, reproduce it multiple times, my compass is what's going to allow me to do that. I take my compass and I open it up to where one leg of my compass is on one endpoint of that segment, and my other, I'm drawing all over, and the other endpoint is on the other leg is on the other endpoint. Does that kind of make sense, everybody? And now, no matter where I take that compass, until I change it, that distance is between the piece of lead and my needle, right? Okay. Now, if I do that, if I take a segment and I start rotating it around its endpoint, what does that create eventually? A circle. Okay. So that idea is that this is a compass. Okay, just a rope, right? Okay. But if I take this rope and I nail the rope into the board here, and let's double it up so it's a little bit shorter. So if I nail this end into the board and I put my marker on this end here, okay, can I trace out a circle? Okay, if I rotate all the way around my arm. So that is just a generic compass. Okay, it's the most simplistic. It's probably in the medieval times and even before that. Okay, ancient times. This is what they use as a compass. If I have a basketball pole at home and I want to make a 3-point line, okay, so from a bird's eye view, okay, here's my backboard, right? Here's my hoop, right? So my post is down in the middle, right? So I take a string that long, right? Okay, I take a chalk or a can of spray paint or whatever, and I keep that line tight and I start walking around, right? Well, won't that eventually create my 3-point arc? Okay. Now, if it's a true 3-point arc, it changes a little bit towards the sidelines, right? Okay, so we would have to take that into account, but that's how we get that arc. If I want to, maybe in my backyard, I want to, plan out maybe where I'm going to put a swimming pool, an above-ground circular swimming pool. Maybe I do this, okay, and I start to trace out the size of that. Or maybe I want to, a garden that's a perfect circle. I could use it. I could put a tent stake in the ground, a rope around it, and I could trace out a circle in my grass, right? And then cut that out and plant some flowers, right? Okay. So those are when we say compass, those are the things we're talking about. Now, my compass that I use in front of you guys is this. It's the same thing, right? Okay. This is one endpoint of my rope. My marker is the other endpoint of my rope. Okay. This piece of steel here is the rope, but it's always going to be straight now, right? Because it's steel. No bend in it, right? Is that all right with everybody? All right. So reading through this, it says when we use online apps to investigate construction. I'm going to try to show you some of this stuff by hand. Okay? There might be, I've got enough compass. I don't want to make you guys go buy a compass because this compass here, a good one, 15 to 20 bucks. And we're not really going to use it enough to really, I think, yeah, justify that 20 bucks. And I don't want you to spend one of those little crappy ones that are like a 99 cents because then you get what you pay for, right? So you're going to get a compass that's worthless and it's not going to produce the things that we want anyways. So I think the online apps and the technology that I give you is going to suffice in being able to do this stuff. The number one reason I want to cover this stuff with you guys, constructions, is because your intercourse exam is going to ask you questions about them. Okay, maybe 1 or 2 questions about them throughout the duration of that test. In the past, before the intercourse exam, I spent an entire month on constructions with students, and I've spent no time on constructions with students. And when that was the case before the intercourse exam, I don't think that there was really a difference, okay, in regards to their abilities. Now, doing the constructions, there will be some things in there that can kind of reiterate and restate some of the information we've already talked about, like midpoints and bisectors and that kind of stuff. But then, like I said, the number one concept right now, the number one reason I want to show this is because of those questions you're going to see later on. We use circles because there's only one dimension that defines a circle. Okay, the radius is the only one dimension that does that. It's the simplest figure that we can reproduce. So we're going to use a circle to do that. It says some of our technology right there is capable of showing just the arc, and some technology is only capable of showing just the circle. Okay, so when I drew, and we're going to see a construction here in a little bit. Actually, let's just do one of the constructions first. Maybe it'll make more sense if I show you how to do it first. All right, so we're going to be given at some point, this is going to be the construction of a congruent segment. So we're just going to kind of try to copy that segment AB. Okay? So I was doing this by hand. The first thing we would do is we would take our straight edge. I'm going to copy this thing here. So that's a portion of a line, right? Or a portion of a ray. So I'm just going to draw a ray that is just a little bit bigger than AB. So obviously that's going to be a little bit bigger, right? Okay, so I'm just going to call that C right now, and I'm going to make, like I said, I'm going to make it a ray, so I should put an arrow there. I want to duplicate AB, segment AB. I want to cut and paste that basically, right? I want to copy it. So then the segment that I create would be congruent to it, right? Well, the way we do that is we take our compass, we put our needle on A, and we put our marker through B, all right? And I'm going to do that, okay? Now, I just showed you the arc, right? And that's all I need, because all I'm interested right here is where that circle, because that arc comes from a larger circle, right? I'm only interested where that circle crosses this red line here in a minute, or this red. But I'm going to come down to C and do the same thing, okay? Now that arc right there intersects that red ray, right? Where they intersect is a point, correct? We'll call that point E. And now what we've done is we've transferred this purple distance down here to that red distance. And those two segments are now congruent. Is that right? What you're going to see in some of our apps that we use is that it has the inability to just show that portion of that arc. It's going to show me that whole circle. Does that make sense? Okay. We don't need the whole circle because everything over here, all of this stuff doesn't come close to intersecting the red. All right. But I don't know how that test is going to be written for you, and the programming that you're going to use to show you a construction. They might show you the whole circle, or they might show you just the arc, right? So I'm going to try to expose you to both versions, but understand every time you see an arc, okay, just a portion of the circle, there is a bigger circle in the background. There's the whole thing in the background. And likewise, if you see the whole circle, you're not going to necessarily need the whole circle. You're just needing the part of the circle that intersects some other circle or some other ray or line. Is that okay? And we'll talk about those things as we keep going through other examples. All right. So know that the arc and a complete circle, they're the same thing. So showing the whole circle creates congested picture. This is a little bit more congested picture. If I look at that, that's a little bit more congested than just that, right? Okay? So by just drawing the arc, we clean the picture up, okay? But when we clean the picture up, maybe we lose a little information, all right? So there's kind of a give and take. Do we want congestion in our picture and a lot of circles overlapping, a lot of lines overlapping? Because that provides me a lot more insight than maybe just the arcs. But the arcs are nice, and just the arcs are nice because it cleans the picture. It makes it simpler to look at, okay? So there's kind of a give and take in that respect of things. So we'll go, like I said, we'll go back and forth between having the whole circle and part of the circle. So the end of course exam, they're not, like I said, they're not going to give you a compass. They're not going to give you a straight edge or anything like that. They're going to probably, and this is what they've done in the past, unless they change it, I would not anticipate anything different, is that they're going to say, okay, here are 15 steps. Explain what we're doing, okay? What do these 15 steps create? Do they create an angle bisector? Do they create a segment bisector? Do they duplicate or cut and paste, copy an angle? Something like that. Or they'll give you 15 steps, say, we're going to construct a congruent angle here. Put these steps in the right order to do that. Or they'll give you 7 steps, say this is a construction for maybe a segment bisector. Tell us which step is wrong. Or tell us which step is dependent on another step. Something like that. So they're going to ask you some qualitative questions about the procedures. All right, so that's kind of what we're going to investigate and look at here as we do this, is the procedure and understanding the steps are important, okay? And the order that we do them is important. And I'll put that stuff in bold. It says you must listen and pay attention to directions within this concept. It's very, very direction-oriented, very procedural. And if I mess up step 1 and step 2, but I get everything else from 3 to 15 right, it's still wrong because 1 and 2 were wrong, okay? So our constructions are going to be very important that we do the steps in the correct order. If you know you're a person that struggles with paying attention to directions, when you come to class, no, hey, I struggle with the directions. I struggle with directions. So when Mr. Fay gives me directions, I'm going to focus on those directions. I'm going to listen and pay attention so that it doesn't become an issue. If you need to, I'm going to go back to videos, okay? I'm going to record everything. Go back to the videos and look at this stuff, okay? All the applets or files that I sent you on Saturday, and there's 5 of them. They walk you through these constructions. Go use those, okay? I'll give you other resources on the web that you can use as well to kind of reinforce these concepts. Right now, we won't have enough math to prove, enough geometry to prove why these constructions work, but after we finish like chapter 4 and 5, maybe we'll come back and say, okay, this is the reason why an angle bisector works, okay? This is the reason why a segment bisector works and that kind of stuff. It does, going through these constructions does maybe give us a different perspective on our properties and rules and all that type of stuff. All right, so what's going to happen is that we're going to learn like 3 or 4 of them this week. Then we'll go like 4 or 5 weeks and learn new material, and we'll do 2 or 3 more constructions. Then we'll go 4 or 5 more weeks of new material and do 2 or 3, 4 more constructions, and we'll keep that pattern throughout the year. Okay. There's a couple other things that happen that way throughout the course. What we learned in 1.8, I think, is going to be the same way, where we learn it once, use it for a couple days, and then 3 or 4 days, or 3 or 4 weeks later, we use it again. 3 or 4 weeks later after that, we use it again, and so forth. Okay. So we talked about construction, we talked about compasses, we talked about straight edge. Let's talk about why we do it this way. Okay. Euclid, we've talked about who this guy was, about 2,000 years ago, he was having these issues, he was having these thoughts and saying, I want to be able to investigate these geometric relationships through shapes, through pictures, okay? I don't want to do arithmetic. We'll talk about why here in a moment that he didn't want to do arithmetic. But it says he uses construction techniques extensively, and they become part of the geometry field of study. And the state and who writes the standards and everything, they say that's important, okay? And that we view this stuff kind of the way he did. It reinforces some of the concepts as well, but they want us to view the geometry and deal with it in the way he did. He had some issues. He says, why? He says, you know, for instance, let's say that I want to bisect a line, or bisect a line segment, okay? If I have any line segment, kind of like this rope, right? Any line segment, we understand the concept that I should be able to fold that, put the endpoints on top of each other, pull it tight, and now my midpoint, when I pull that back out, where my left hand would be the midpoint of that initial segment, right? Does that make sense to everybody? Okay? We know that point should exist. He has proven that and shown that with some of his postulates and theorems and that kind of stuff. But based off arithmetic, he kind of ran into a problem here, okay? And this is why. If I am in 2000 BC working with the Greek number system, it's not the same number system that we use today, okay? It's more aligned with the Roman numerals, okay? You guys have dealt with Roman numerals, right? Ever try to add them, multiply them, divide them, subtract them? It's complex, right? It's a pain in the butt, okay? Where our number system's different because it's got place values, it's very consistent and powers of 10 and that type of thing. And it allows our arithmetic to be more natural than it was for them, okay? So that's a problem. And there's another issue that's at hand. I kind of explained this the last class. I said there's two schools of thought in regards to mathematics. One school of thought is that mathematics has been here ever since the first moment of creation, okay? And that we as humanity have been just uncovering it. We've been discovering it, and then we use it for some purpose, okay? There's another philosophy that says we as humanity are inventing this math, okay? Understand there's a difference between discovering it's all out there, and now we're just kind of pushing the curtains aside and discovering it, okay? In comparison to developing it and creating it, inventing it. Does that make sense? It's an opinion. Whatever you feel it, the situation is, I feel that we're discovering it, okay? But if you're a person that says we invent it, that's fine. There are some aspects that maybe it makes sense that you could say that we've invented it, but I think there's a lot more aspects that says we're just uncovering it. Math is what the structure that allows us to explain all interactions throughout our existence, okay? How everything in nature, when I say nature, I mean in our environment, okay, interacts with one another, okay? If you think back to like these times, okay, 2000 BC, okay, we're thinking, I don't know if it's 2,000 years, I gotta check my dates on this, but BC time, okay, he was alive BC. And you think about the interactions that occurred mostly and why maybe we would need certain math in regards to those interactions. Think about shepherds, okay? If I'm in charge of a flock of sheep, okay, and the reason I have these sheep is so that I can barter with other people, so that I can trade them sheep so they can give me other things, right? Maybe they give me other meat, maybe they give me clothing, that type of thing, right? That's kind of how economics worked back then. Okay, so let's say I've got 5 sheep, and I come up to Lex, and Lex has 10 cows, and I say, Lex, I'll trade you 3 sheep for 1 cow, okay? So all we needed there were numbers of 3 and 1, right? Okay? I never needed a fraction. I never needed half of something, right? Okay? So we do this bartering system, and I only need numbers like maybe the Roman numerals and stuff like that in order for this bartering system to work, okay? But maybe I'm a shepherd, and all my flock dies or runs away from me or whatever, and I can't find them. Roman numerals don't have a way of describing that numerically. What would the number be describing that? If I have no more sheep, 0, okay? Roman numerals didn't have that. So we need to then create a system that incorporates it, so we can explain the absence of something. That's what 0 means, right? Okay. So we maybe discover 0 or we invent 0, however you think about it. So now I've got 0 to deal with. Okay. In this bartering system, I'm trading live animals. I don't need halves. But let's say I start trading meat. Me and Lex are going to trade meat. Now I'm going to trade Lex 2.5 sheep for 1/3 a cow of just the meat, right? Does that mean that I need fractions to be able to do that? So then we need to discover these fractions or how we're going to do that and design a system that's going to allow us to do that so that we can. So the way we interact and do this bartering system is trying to help us develop the use of certain values, right? Certain numbers. The Greeks didn't have fractions. They didn't have 0.5, 0.25, that kind of stuff. Okay? They just had whole numbers. They just had to start in at 1, so they didn't have whole numbers. They had natural numbers. Okay? And they had issues that if I gave you a segment that was 7 units long, maybe just 7 inches, and Euclid had problems now saying that when I cut that in half, I get 2 segments that are both 3.5 inches because they didn't have 0.5. Does that make sense? Okay? So this is why he started using these constructions, the compass and no measuring, to try to find and locate that midpoint exactly. Another reason is basically what you guys have seen maybe in chemistry so far. If I wanted to measure that, okay, if I wanted to measure that segment, I would put my ruler up. I would put my measuring device up against it, right? And maybe it falls between 7 and 8 inches, and that's all I've got on my ruler is inches. Can you tell me the accurate distance of that segment? No, you can just tell me it's bigger than 7, right? Bigger than 7 is smaller than 8. So then what do? We start doing what to our ruler? Yeah, we start making smaller intervals, right? Okay? So maybe I go 7 1/4, 7 1/2, 7 3/4, right? So now it's a little bit better. So now you can say maybe that red dot, that endpoint ends a little bit after 7 1/4. So you've got a more precise answer, okay? It's not accurate, maybe, okay? It's not the true value, right? Okay? But it's better than what it was. So we keep doing that, right? And we go down, okay, so if it's enforced now, maybe the next thing I do is I break it into 8s. But then won't that endpoint be somewhere between 2 8s, 1 8 and maybe 2 8s? And then I break down to 16ths. So maybe it's between now 2 16ths and 3 16ths. Okay, so that game, it's the same game that it was between 7 and 8, but now it's just on smaller intervals, right? And we keep doing that down to 30 seconds and 64s and 128s and 256s, 512s, 1024s, and keep doing that. But that point will always be somewhere in between two values, right? So I'm not going to have the true distance of that thing because my tool that I use, my device, is not precise enough to do that. Does that make sense? Okay. So what do? We use a compass and a compass and a straight edge, and it will find me the exact midpoint, wherever that may be. It will find me the exact midpoint with total neglect of measurements. Does that make sense to everybody? We will not have to use numbers or anything like that. That idea of breaking it down to 1/16, 30 seconds, and 64ths. Did you guys have that discussion when we talked about sig figs? Okay, that's one of the purposes of sig figs. Okay, is because of that idea that we are never going to be able to get an instrument. And we have a lot of technology that helps with this. We have very accurate scales. We have very accurate measuring tools, rulers that are lasers, right? That will find those distances very, very, very close, but not the exact distance, not the accurate distance, right? Does that make sense to everybody? Precision's the idea of being able to replicate a distance or measurement over and over and over again, right? And accurate is being able to get to that true length of that object. Okay, so hopefully you've talked about that. But that's what he was concerned about. So we come up with these constructions and these geometric constructions that have validity and proof behind them that will allow us to cut an angle in half, exactly, regardless of what size the angle is. Cut a segment in half, regardless of the size of the segment, that type of stuff. Is that all right with everybody? So that's kind of what we're going to do tomorrow. Last class got a little bit further. I was able to show them some of these files, one of these files at least. No homework tonight, even though there's one on Math Excel. Don't worry about it. It's not due tomorrow. And I'm not going to go in and fix the due date for it right now, so just know that don't have to do it. But we're going to use this site here quite a bit. Everything that I do in GeoGebra, I'll give to you in a file, but we can also find it here in a video kind of idea or a different applet that actually shows you a visual compass, like the one you would hold by hand. Okay? GeoGebra doesn't show you a visual compass. Okay, that's the only kind of downside to it. Is that all right with everyone? All right, a lot of kind of like history and all that kind of stuff and understand why we do things. I don't want. I hated sitting in class and saying that we're just going to do it because I said we're going to do it. Mr. Leidy said we're going to do it. Well, that's not good enough for me. I want to know why we're doing it. Okay, so that's the way I kind of explain things.